These would be, most of these are basic type level for target 15 on solving a polynomial completely. So for the first one, what I would do is I would use the factor theorem and say, if x minus 2 is a factor, then is f of 2 0? Because if x minus 2 is a factor, f of 2 is going to have to be 0. And this one, f of negative 2 would have to be 0. Okay? I think this is probably making it a little easy because they just have the repeated ones in there. But there could be other ones in there as well. So basically, we just need to see which of these two is a 0. And maybe there's a double. I'm not sure. So I'm going to use synthetic division on this. So I bring down my negative 2. I double check, make sure these are in the right order. There's no missing terms. I multiply that negative 2 to the 2. And then I add. Here, negative 5. Then I take negative 5 times 2 to get negative 10. And I add that to the 9. Then I take negative 1 times 2, and I get negative 2, and I add that to the 4. So what I've done is I've just shown that 2 is not a 0, so x minus 2 is not a factor. So let's try the same thing with negative 2. And as you can see, it works out to be 0. So f of negative 2 is 0, which means x plus 2 is a factor. So that would mean I could rewrite, if this were the function here, I could rewrite it as x plus 2 is one factor, and what I'm left with is right here, times negative 2x squared plus 3x plus 3. And then I don't believe the other part is factorable, but it's not asking for any of that. So I don't think x plus 2 is another factor. So there was only, I guess you could have selected either of those x plus 2's. So remember, part of the process here is trial and error, seeing if a value is a 0, so you can determine a factor. So B or D would have been fine there. For number 2, don't forget your rules for factoring that we learned back in, I think it was target 14, and then also just factoring for quadratics, which I think was target 4. So the first rule is to factor out the GCF. I can factor out a v squared from both of these. If I do that, I'm left with v plus 5. Check by distributing. V squared times v is v cubed. V squared times 5 is 5v squared. So then you use the zero product property. Find the values that make the first factor v squared equal to 0. Find the values that make v plus 5 equal to 0. So this one you could subtract 5 and get v is negative 5. This one you could square root both sides, you get plus or minus 0, which is just 0. But what that means is 0 is a double root. So if we're thinking about what the graph looks like, if this were a function right here, it would have an x-intercept at 0 and an x-intercept at negative 5. It is positive leading coefficient with odd degree, so it's going to end going up, but this one will be a double root. So its general shape is going to look something like that. You didn't have to do the graph for this one, but I was just kind of tying that back to a previous target with graph. So again, the answer to this one is 0 and negative 5. Now for number 3. So identify the zeros of this one. So this is where you're going to have to look at your leading coefficient and your constant term, and basically list all the factors of the constant term, plus or minus all the factors of 360, so 1 and 360, 2 and 180, 3 and 120, etc., etc.
4 and 90.
490, 5 and whatever that is, and then divided by all the possible factors of 2. So that one's a little simpler. That's a shorter list. And you have to start trial and error and finding one. And you could use a table on a calculator or technology. You could use synthetic division, but I think what you'd find is that 5 is a factor of 360. What is that? 72, I think. 5 times 72 is 360. And 5 is one of them that you might have stumbled across. So I'm going to do synthetic division. And at some point, with trial and error, hopefully I would stumble across that 5 is a 0 by doing this. So bring down, multiply, add, multiply, add, multiply, and add. So that we just proved that f of 5 is 0. So that means x minus 5 is a factor. So if I were rewriting this, I could write it as x minus 5 times, and then this is what's left, negative 2x squared minus 24x minus 72. And then what I have here is I have a quadratic. So I could solve that by factoring or the quadratic formula. If you factor out the negative 2, you're left with x squared plus 12x plus 36. So with that negative 2 factored out, x squared plus 12x plus 36 is going to factor to x plus 6 times x plus 6. Factoring that, two numbers that multiply to 36 and add to 12 are 6 and 6. So my zeros are 5 and negative 6. And again, negative 6 is a double root. So there's actually only 2 solutions to this cubic equation, or 2 zeros. Remember, when we look at the degree, that tells us the maximum number of zeros or roots of the function. And then the last one on this one probably isn't more basic. This one's probably meets exceeds. But if you were to do that again, and take all the factors of 14, so 1 and 14, 2 and 7, plus or minus all of those over the factors of 1, and try these 8 possibilities, 1, 2, 7, and 14, and their negatives, none of them work. What that tells you is there is no rational zeros. But this is a quadratic form equation. So we can factor this like we factor a quadratic, finding 2 numbers that multiply to 7 or 14 and add to negative 9 because the leading coefficient is 1. So negative 7 and negative 2 multiply to 14 and add to negative 9.
And then would there
But
be,
instead of having a b and a b, I'm going to have a b squared and a b squared. Because that's what makes it b to the 4th power when you take b squared times b squared. So now I can just solve these 2 factors equal to 0. So this b squared minus 7 equals 0. I could just add 7 to both sides and then square root both sides. Square root of b squared is the absolute value of b, which means b could be, b could be either positive or negative square root of 7. There's 2 solutions. They're irrational. Doing the same over here, add 2, square root, you'd end up with plus or minus the square root of 2. So there are your 4 solutions. Positive square root of 2, negative square root of 2, positive square root of 7, negative square root of 7. Questions? Yeah, Julian?
We'll get like, for the last one there.
Mm-hmm.